Hi everyone, and welcome to today's Chemistry Daily Booster. This is number 4 in our series. Now, do note that the purple box is back because this is one of the advanced information topics that's been listed for the foundation chemistry paper. That's not to say it won't come up on the higher tier, but it's just not being explicitly listed as coming up on the higher tier. What we're going to be doing in this booster is having a little look at some key properties and how we actually describe the structure of an atom. So the first thing, let's dive into these properties. There are two types of property we need to know about: physical properties and chemical properties. The physical properties, first of all, are characteristics that we can either observe or measure. So two kind of categories that they like here I've given to you on the screen. Something may either be malleable or brittle. If something is malleable, that means we can bend it without shattering, whereas if it's brittle, it will shatter when you hammer it or try to bend it too much. The other one, ductile, means that we can pull it into wires. Non-ductile means that it's going to snap when we try and pull those ends. Chemical properties are the second one, and a chemical property is a characteristic that we can only determine by studying chemical reactions. So, examples here: metals and non-metals reacting with oxygen to form oxides. We do need to know how we can identify if an oxide of unknown origin is a metal or a non-metal oxide. And it's as simple as you dissolve it and then you test the pH. So metal oxides will produce alkaline solutions, non-metal oxides acidic solutions. The next thing we come on to is the first introduction, if you like, to the periodic table. Now, don't forget, you get a copy of the periodic table in your chemistry exam. So it's on that little data sheet that some people fail to ever turn over. So when you go in, you're going to have your question paper and you'll have a data sheet. Turn the data sheet over, you will find the periodic table. Now, the one they give you in the exam is incredibly useful, because actually there's a whole load of information on there, not just the elements, their symbols, atomic numbers and atomic masses, but it even gives you the key. So what we find is, even if you can't remember which is which, we will still have this little key sitting there on the one you get in the exam. Okay, so you've got no excuse for mixing up atomic number and atomic mass, because it's literally printed on the actual periodic table. So, key things about the periodic table. First one, metals are on the left-hand side. So this is all a lovely metal section. So all the metals on the left. On the right-hand side are the non-metals. So non-metals on the right, metals on the left. What we do have, and you can see it in the little blue coloured bits here, then there are some elements that sit on the boundary between metals and non-metals. And the reason we've coloured those blue in this little diagram is because they actually have properties of both metals and non-metals. So they're a bit quirky, if you like. Now, two terms we need to know: period and group. When we talk about periods, those are the horizontal rows, so going from left to right. Now, what we actually find is the most common way people mess up on the periods is they forget that the first period is actually here, where we've got hydrogen and helium. So the first period has just hydrogen and helium. Your second period then starts with lithium, third one with sodium, and so on. So what we can see is, literally, as long as you remember hydrogen and helium, it's a counting exercise. The groups are the vertical columns, and when you look at the periodic table in your exam, you'll notice they've labelled some of these on there for you. So vertical columns are the groups, horizontal rows are the periods, and don't forget, any of the elements that are in the same group have similar chemical properties. If they ask you to explain why, it's because they have a similar arrangement of electrons, or you could say the same number of electrons in the outer shell. And that brings us very nicely onto how electrons are arranged. As we established in our earlier little booster, then electrons are arranged in these shells or orbitals around the nucleus of the atom. When we want to show how the electrons are arranged into these different shells, we use something called the electronic structure. Now, there is one other term we need to make ourselves aware of before we move on, and that's this term outer shell. What we're referring to is the outermost shell that is occupied by electrons. So we can use outer shell for that. Don't just say shell. If you're talking about the fact that group 1 have 1 electron in their outer shell, make sure you use the phrase outer shell. We have 4 rules that we need to learn for GCSE, and this is telling us how many electrons we find in each of the shells. They're maximums, okay, so it could be up to that number. So the first shell, the one closest to the nucleus, a maximum of 2 electrons. Second and third can hold 8 electrons each, and the fourth shell is 18. So realistically, as long as you remember 2, 8, 8, if you've got anything left over, just goes into the fourth shell. Because as far as GCSE is concerned, then that's as far as you're going. Now, when we've actually got our electronic structure, we could have something like that. So 2.1. Now, this gives us a lot of information, just those 2 numbers. First thing, it tells us what period it's in, because however many numbers there are, in this case we've got 2 numbers, so it is in period 2. The last number, so this one here, is going to tell us the group number. So this one is in group 1. And if we add up the 2 and the 1 together, we've got the atomic number. So the atomic number in this case is 3. Sorry, terrible writing there. They could potentially ask you to draw one of these little electronic structures. So they could obviously get you to look it up on the periodic table. They could tell you in the question that it has an atomic number of 7 and ask you to draw a dot and cross diagram to show this. So all we're going to do is, if we use the example I've just given there, so we have 7 electrons that we need to do because it's got an atomic number of 7. So we start off with our first shell. Now we can have a maximum of 2 electrons there, so we're going to put 1 cross, 2 crosses. So 7 minus 2, we still have 5 electrons to go. So we add a second shell here, and then we're going to start to add our electrons up to a maximum of 8 in the shell. We've only got 5 to play with, so they can all go in. So 1, 2, 3, 4, 5. Then write out the numbers. First shell, we've got 2. Second shell, we've got 5. And that's it. That's all you need to do there. So from that we can see this one is in group number 5. It's going to be in the second period because we've got 2 numbers. And of course the atomic number is 7. Final thing to do then is head on over and have a go at the quiz for the day. Obviously, if there are bits that you're still not sure on, then use the video on the main channel just to support you with that, your revision guide, your actual classwork, and make sure you are very confident in this. Don't forget to join us again tomorrow for our next chemistry booster.